Ninth standard, maths part first, lesson number 2, real numbers. Students, we have studied what is mean by rational numbers. Now, what is mean by irrational numbers? Numbers which are not rational are called irrational numbers. Decimal expansion of irrational numbers is always non-terminating, non-recurring types. And irrational numbers are root 2, root 3, root 5, root 7, pi are some irrational numbers. Then what is mean by real numbers? The numbers which can be represented on the number line are called as a real numbers. We can indicate irrational numbers and rational numbers on the number line. Therefore, irrational numbers and rational numbers are real numbers. We cannot find the negative square root of the real numbers. That is, negative square root of the real numbers is not real number. Now, to prove root 2 is irrational number, let us see how to prove root 2 is irrational number. Let us assume root 2 is rational number. As root 2 is assumed as rational number, this root 2 can be represented in P upon Q form. Therefore, we write root 2 is equal to P upon Q, where P upon Q is reduced form of rational number, and there is no common factor. There is no common factor between P and Q other than 1. P upon Q is a reduced form, that is lowest form. So there is no common factor for P and Q other than 1. Now square this equation on both sides. Root square is a 2, root 2 square is a 2. P upon Q square is P square upon Q square. Squaring on both sides. Therefore, we get 2Q square is equal to P square. Here, Q square is multiplied by 2. If we multiply any number by 2, then that number becomes even. Therefore, 2Q square is even. Therefore, P square also even. Therefore, P square is even number. Therefore, P is even number. P is even number. Let this equation number 1 and this is equation number 2. We know that square root of even number is always even number. For example, square root of 4 is a 2. 4 is even, 2 is even. Square root of 36 is a 6. 36 is even, 6 is even. As p square is a even number, therefore its a square root. P is a even number. Therefore, as any even number can be written in the form of 2 as a factor. For example, 2 can be written as 2 into 1, 4 can be written as 2 into 2, 6 can be written as 2 into 3. Therefore, as p is a even number, this p can be written as 2 into t. T is any integer such as 1, 2, 3, just like. So t is a integer here. T belongs to I. I indicates integer. Now squaring on both sides, we get p square is equal to 4t square. Squaring on both sides, let this be the equation number 3. Now let us see equation 1 and equation 3. In equation 1, p square is equal to 2q square, and in equation 3, p square is equal to 4t square. Therefore, we can write 2q square is equal to 4t square. Therefore, we write q square is equal to 2 into t square. Divide both the sides by a 2. 2q square upon 2 is a q square, and 4t square upon 2 is a 2t square. Let this is equation number 4. Now q square is equal to 2 into t square. As t square is multiplied by 2, then 2t square is a even number. Any number multiplied by 2 is always even number. Therefore, we write q square is even number. Q square is a even number. Therefore, q is a even number. Q is even number. This is equation number 5. Now, p is a even number. Therefore, 2 is a factor of p. Any even number has a factor 2. Q is a even number. Therefore, q has also 2 as a factor. Therefore, p is a even number. Therefore, p has 2 as a factor, and q is even number. Therefore, q has also 2 as factor. P has a 2 factor and q has a 2 factor. Therefore, p and q both have a q as a factor. Therefore, p and q has 2 as common factor. But here we have written that p and q has no common factor. Therefore, this contradicts. This is contradictory. Therefore, this contradicts. Therefore, our assumption root 2 is rational number is wrong. Therefore, root 2 is irrational number. Let us see once again to prove root 2 is irrational number. Let us assume root 2 is rational number. We know that any rational number can be represented in the form of p upon q. Therefore, we can write root 2 is equal to p upon q, where p upon q is the lowest form, that is reduced form of rational number. So p and q have no common factor other than 1. Now squaring on both sides this equation, root 2 square is a 2, p upon q square is a p square upon q square. From this 2q square is equal to p square. If we multiply any number by 2, then that number becomes even number. So multiplying q square by 2, 2q square becomes even number. That means p square is a even number. Therefore p square is even number. And square root of any even number is always even number. Therefore square root of p square is a p. P is a even number. Therefore p has a 2 as its factor. Now let p is equal to 2 into t. As p has a 2 factor, so any even number can be expressed in the form of factor 2. Therefore we can write p is equal to 2t, where t belongs to I, that is t is an integer. Squaring both sides, p square is equal to 4t square. Now here we get p square is equal to 4t square, and from equation 1 p square is equal to 2q square. Therefore write 2q square instead of p square. Therefore 2q square is equal to 4t square. Dividing the equation by 2, that we get q square is equal to 2t square. Here t square is multiplied by 2, therefore 2t square is an even number. Therefore q square is also even number. And the square root of even number is always even number. Therefore square root of q square is a q, which is also even number. In this way p is a even number. So any even number has a 2 its factor. So p has a 2 factor. And q is also even number. So q has also 2 as a factor. So p and q has a 2 as common factor. But we have there assumed that p and q have no common factor. Therefore this contradicts. Therefore our assumption root 2 rational number is wrong. Therefore we can say that root 2 is irrational number. Practice set 2.2. Question number 1. Show that 4 root 2 is irrational number. Now let us solve this question. Let us assume that 4 root 2 is rational number. As 4 root 2 is a rational number, it can be represented into p upon q form. Therefore we can write 4 root 2 is equal to p upon q, where q not equal to 0 and p comma q belongs to I. That is p and q are the integers. Now squaring on both sides, or we can write here don't square, root 2 is equal to p upon 4q. This is equation number 1. From equation 1, p upon 4q is a rational number because p and q are integers, and integers are rational numbers, and root 2 is a irrational number. Therefore the right side of this equation is rational number and left side of this equation is irrational number. This is a contradictory. Therefore, our assumption that 4 root 2 is a rational number is wrong. Therefore, we write 4 root 2 is irrational number. So here we write right side of equation 1. Right side of equation 1 is rational number because P and Q are integers. Left side of equation 1 is irrational number. Therefore, this is contradictory. Therefore, our assumption four root 2 is rational number is wrong. Therefore, 4 root 2 is irrational number. Now question number 2. Prove that 3 plus root 5 is an irrational number. Let us solve this example. Let us assume that 3 plus root 5 is rational number. We know that any rational number can be represented in the form of P upon Q. Therefore, this 3 plus root 5 can be represented in the form of P upon Q, as it is assumed that 3 plus root 5 is rational number, where Q not equal to 0 and P comma Q belongs to I, that is P comma Q are integers. From this equation, find the value of root 5. Root 5 is equal to P upon Q minus 3. This is equation number 1. Now see this equation. To the right side of this equation, P upon Q is rational number and 3 is also rational number. Therefore, P upon Q minus 3 is also rational number. So right side of equation number 1 is a rational number and root 5 is a irrational number. This is contradictory. Therefore, our assumption 3 plus root 5 is a rational number is wrong. Therefore, 3 plus root 5 is an irrational number. Now write right side of equation 1 is rational number. Left side of equation 1 is irrational number. Therefore, this is contradictory. Therefore, our assumption 3 plus root 5 is rational number is wrong. Therefore 3 plus root 5 is irrational number. Now question number 4. Write any 3 irrational numbers between the two numbers given below. Between any two rational numbers, there are infinite rational numbers. We can write infinite rational numbers. Number 1 is a 0.3 and minus 0.5. So we have to write the numbers, rational numbers between 0.3 and minus 0.5. So that numbers are 0.2, 0.1, minus 0.1, minus 0.2, minus 0.3. In this way you can write infinite numbers. Now example number 2. In this example we have given minus 2.3 and minus 2.33. Here we write minus 2.300. Put 2 zeros on 3 and here we write minus 2.330. Now we can take the rational numbers between these two numbers as minus 2.301 minus 2.302. In this way minus 0.308. Any number can you take? Minus 2.329. You can write infinite numbers. Now here 5.2 can be written as 5.20 and 5.3 can be written as 5.30. So numbers can be written as 5.21, 5.22, 5.23. In this way 5.29. Now minus 4.5 can be written as minus 4.50 and minus 4.6 can be written as minus 4.60. So rational numbers we can write here minus 4.51, minus 4.52, minus 4.59. In this way you can write infinite numbers between these two rational numbers. Now students, here is homework for you. Homework is practice set 2.2, example number 3, that you have studied in 8th standard how to represent number root 2, root 3, root 5, root 7, root 10 on the number line. And this example is to represent the number root 5 and root 10 on the number line. So this is homework for you. Thank you.